to go to the next room if you're interested by the social web and social APIs and the open standards. And here we have our internationally famous open source guru. Yeah, it's you I'm talking about. It's please welcome Chris DiBona. Don't forget to go to the breakout room if you want to hear more about social web. Here it's about open source, and Google and open source. Thank you. Thank you for being quick, trying to catch up. The floor is yours, Chris.
Thanks,
Start when you want.
I appreciate it. Everyone hear me? Yeah, you can hear me fine. I'm going to let people mill out for a bit. And so, yeah, hi. My name's Chris DiBona. I look after... What's that? Until 50 you have. Until 10 to. Okay, that's fine. Thanks, Sebastian. So, yeah, I look after open source for Google, a small company in Mountain View, California, and here and everywhere else. Is that better? Does it sound better for all of you? Yes, okay, good. Yeah, I've been working for the company for about 6 years, and it's sort of an unusual job in that while so many Googlers are concerned with products and launches and all the rest, I'm concerned with making sure that if you want to take the code that we produce and run with it, that you can do that in a lot of cases. And that's what this talk is about. So I'm not big on agendas, so and we're probably a little compressed for time, so if you have any questions for me, I'll be at the demo pods after my talk. Happy to chit-chat. So first, let's talk a little bit about open source. How many of you know what open source is? Just raise your hand, like this. Both hands. No, I'm kidding. So enough of you don't, so let me just do the 30-second introduction to what it is. It's software that's free of charge. It's software that if I release it and you take it, you can use it, you can ship it, and in many cases you can charge for it. It is software, suppose I release a piece of software that manipulates some text file and you decide to use it to operate a robot. That's fine. I cannot tell you what you can't do with the software that I release if it's open source. And it has source code available. So a lot of people don't realize that open source, it's one of the requirements that the code become available for it to be considered open source. And it's licensed under an open source license. There's two basic kinds of license. One that says you must share the code that you get from someone if you use it and ship it to your customers. And the other kind, about half of it, that says you don't need to do that. That all you have to do is acknowledge that you're using it. You don't have to share your code. You don't have to share modifications. So there's two sort of ways that come out of open source licenses. So this would all be academic and kind of boring and just sort of an intellectual exercise if it wasn't for the fact that there was so much open source code out there. We did a scan of the entire internet, and we found about 31 million files that were licensed under an open source license, amounting to about 2 billion lines of code. This is the equivalent of about 10,000 software developers working for about 10 years. This is a serious resource for anyone who wants to create a company, wants to do consulting, wants to create software. And Google, too, realized this, and we wanted to take advantage of this and do a good job of it. One of the things that a lot of people will ask when first introduced to open source is, why do people do it? Why do they release open source code? Why do they take something that we all know has significant value and just give it away? And it sort of comes down to the ideals behind computer science in the first place. So, there's a lot of jobs out there, and when you think about the technical jobs and the jobs you see in research and the rest, you don't really want to have to redo all this work every time you go to a new company or a new effort or start a new project. You want to start on top of the shoulders of giants. In mathematics, you would never think that you would have to rediscover the midpoint theorem before doing trigonometry. You would never think that you would be required to rediscover the calculus before launching a rocket. It's already known. It's already discovered. There's no point in having to go down that path of research that Riemann and Leibniz and all the rest went down hundreds of years ago. So yeah. So in a lot of ways, that's why open source exists at all. It's because people want computer science to proceed. They want their lives to be better as they go from job to job. And very few people, you see this one at the bottom here about disliking proprietary software, very few people hate and have that be their motivator. So the one at the bottom is, I hate Microsoft, that's why I do this. And and there's very few people who feel this way. It's only about a tenth, which is kind of nice. Most people just want to advance the science and make their job better. So that's pretty cool. So Google. This is Google. You might recognize the high technology that is Google. So when we started some 12 years ago now, what our founders would do is they would walk down the hallways of their lab building, and they would steal, well, borrow, the computers that were not plugged in, and they would appropriate them for their use in their research, which is very computationally expensive, the idea of tracking link propagation through the web. So they gathered together all these machines, and if people got upset, they'd give them back, and they ran their experiments. And what they did is they basically took these Unix machines, and we have some Sun machines, some IBM machines, but most of them are just PCs running Linux. And they just did their experiments, and nobody really stopped them, which was pretty nice. And I don't know if you noticed this thing up here, this Legos. That was sort of their hard drive array holder. But as we became a real company, and we had a little bit of money, we had a choice. We could go out there and spend a staggering amount of money at the time to us on large servers from Sun or from HP. We could buy fault-tolerant PCs from Dell or from IBM or from any of those vendors. But what we needed is we needed computational capacity. We needed storage, and we needed memory. And to buy those things from the standard micro vendors at the time meant spending an awful lot of money. So for the cost of a fault-tolerant, and I say that very, very loosely, fault-tolerant machine from Dell in 1999, you could get 2 racks of junk like this. Okay, and this junk, and I call it junk for a reason, was in a lot of ways more reliable, more useful, and certainly more capacious and more powerful than that fault-tolerant machine. At the time, by the way, RAID was nothing great in in PCs, and in a lot of ways, you end up spending a lot of money for not a lot of actually extra capacity or extra reliability. So what we decided instead is, you know what, we're going to have to build reliability into our software anyway, so why don't we take a disposable approach to our hardware buying, right? So what we did is we followed all of you to the store. I mean, virtually, not really. We weren't like following behind you. And we bought the same hard drives that you were buying, the same CPUs that you were buying, the same chips, the same chipsets, the same everything that you were buying. And we were putting them in racks like this. So basically in a 2U, what you're seeing here, so in this space here, you're seeing 4 machines, 4 CPUs, lots of memory, 8 hard drives, 2 power supplies, and 4 network cards. So can anyone tell me what's wrong with this? Just raise your hand if you can see anything wrong with this installation. You won't be wrong, I assure you, yeah. A lot of wires, yeah, it's true. So in a lot of these, and now, of course, in many data centers, you'll see these very neat bundles of cable going everywhere. Well, this wasn't exactly neat. And so the price we paid for that is if one of these broke and we wanted to pull it out to fix it, these cards and the motherboards would catch on the wires, and sometimes they'd snap off. So that was bad. Any other problems with this design? Yes? Heating, yes. Okay, so what happens, I don't need to tell people who live next to a desert that heat rises, right? So the heat would rise up. Those fans in the back would try to get rid of the heat, but it would still get very hot up top. And we had a couple of these where the hard drives were bad. The solder was a little too soft in them, so the hard drives in the very topmost machines were melting and dripping solder on the machines below them. So that was bad. Also, we hit this sort of idea that, if one breaks, we'd have to shut down 4 of them. We had all these problems, but it actually did the job. It kept Google running. It kept our algorithms running efficiently, and it was cheap. So we actually adopted this idea that if one machine went bad of the 4, well, yeah, we just leave it there. We don't bother replacing it. We just let it die. So it's sort of like this corpse in the midst of all this liveliness. So then we got a little more advanced with our amazing cooling technology over here. So I used to work at the time when this was going on back in, I think, 2001, 2002. We had a fan like that in our data center at SourceForge, and it actually caught on fire. So it did make things cooler, let me just say that. But again, you're looking at consumer-grade hard drives, consumer-grade motherboards, machines, really just put together for speed and, in some ways, disposability. And we would put all of our intelligence into the software design and providing reliable services that way. And we got better at it. We used more and more power, and better still. And this is sort of where we are today. You know, we have these racks still wide open to allow more airflow. You know, we do things like align the memory cards so that they were with the airflow as opposed to against it, and, you know, clever things like that. And they're a lot more maintainable now. You know, Velcro for the hard drives, you know, to put them into place, which is a lot smarter than it sounds. You know, and so they were very efficient and very powerful in a small amount of space. And that's been very good for Google. And we've taken it the next step. We have our own data centers and all the rest, but it's still the same CPUs, same hard drives, same chipsets that you're all running, because honestly, it's the best bang for the buck that you can find. And then running open source on top of it. So whenever you visit Google, you're using Linux. So you're all Linux users today. And then on top of that is software that we've written using open source languages, Python, GCC, Java, etc., and combined with open source libraries. Literally tens of millions of lines of code that were not written at Google are being run at Google, along with our software. And so that's what Google looks like. And then we have our own workstations that engineers run. And those are just running a version of Ubuntu that's specific to our network environment. So, but why? Google's a big company now, right? We can afford to go to Jordan and talk to all of you and feed you and give you mugs if you ask questions, or like Barcelona over Real Madrid, whatever. And I don't know much about soccer, so or football, so yeah. So that's about the limit of my knowledge. But why do we do it? You know, we can afford to buy software now. We can afford to buy even reliable machines if we want to. So why do we do it? And that's why I'm going to tell you a story. Back in 2004, France Telecom wanted to ship the push-to-talk feature on their cell phone networks. You know, we go, and it's like a walkie-talkie, right? So they spent about $2 billion, US dollars, on upgrading their network in France. It was very expensive. And they planned a new phone. They had spoken with a Taiwanese vendor of phones, and they had picked Windows Mobile for the phone. This is not an anti-Microsoft talk, I should point out. It's a what happens if you don't control your destiny. They just get sucked into that. And as they got closer and closer to launch, every fifth was dying. It was, you know. And they isolated it down to this one module in their mobile operating system, and they said, that's a real problem. Let's call up our vendor. They call up the vendor. They say, hey, you know, what's going on with this? This is broken. And they said, well, yes, we know. And they're like, oh, magnifique. Great, you can give us a fix. They said, well, the fix isn't out until the new operating system version. They said, oh, okay, well, when does that come out? And they said, 18 months. 18 months? We ship in 3 months. They said, well, you know, I'm sorry. Well, can't you give it to us early? And they said, no, we can't. Because they did that calculation that software companies have to do when asked to have a special version of an operating system or a special cut of the operating system. Is it worth the money that it costs to have a special version, to spin out the support costs and the extra everything that goes along with it for one customer? And is that one customer worth it? And in the case of France Telecom, they really were only about 4% of all Windows Mobile revenue. And this one phone itself was not that important from a percentage of sales point of view. So they decided it wasn't in their interest to do that. And that was probably a logical decision on Microsoft's part to do that. But it left France Telecom hanging. And so they turned the button into a mute button, or a camera button. I honestly don't remember which, but it wasn't a push-to-talk button. And they had another phone coming out running Symbian in a couple of months. But that was 2 months when they couldn't monetize this $2 billion outlay of expenses. Now let's draw a parallel. At the same time, we wanted to change Linux to run processes that were not running as the super user to use ports that were under 1,000 in TCP/IP. Now, for a lot of you, you don't know much about TCP/IP, or maybe you do, but the point is most user programs can't do that. And it's a limitation of the operating system. They tell you not to do that to secure things. So we said, hey, but we look after our machines well. We have our own kernels, we have our own everything, so why don't we just fix it and push it out? And so that's what we did. It took us about 5-6 days, and we had it out to our entire network of machines very, very quickly. So, in the process of doing that, we didn't have to call a vendor and ask permission. We didn't have to tell that vendor how many CPUs we'd be running on. We didn't have to tell them how many hard drives we had, how many threads we'd be running, how how much memory we'd be exploiting in the process. And these are all things that come up when you borrow software from other people that you can't run yourself. I was at a conference of lawyers in the United States, and they were telling me how they had to tell their engineers, listen, I know you like this new CPU of yours, but I need you to shut off hyper-threading and I need you to shut off the other cores. Because if you turn them on, the cost of our database is going to quadruple or be 8 times as much as it is today. And it's like, as an engineer, this is deeply offensive to me. So that's why we use it, among other reasons. I mean, we like it, so it's who we are. And I could stop my talk there, and maybe Sebastian would want that, but I'm not going to. Because one of the things is if you start really using open source like that, it's really in your interest to understand where the software you're using is going and how it's going to mature. So we try to do a couple things to ensure the health of open source. So first, we offer project hosting on code.google.com. Any of you could, right now, create a project in 30 seconds, or however fast you type. And then you'll be able to develop open source software online. We offer wikis, bug tracking, version control, simple hosting. So it obviously resonated with the community of open source developers, and we have a little over 330,000 registered projects there today, with about 50,000 of them doing a change in version control every day. So that's very exciting to us. It really helps, But in a lot of ways, the currency of open source software development is the release of code. So we've made it our mission to enable Google engineers to work with all of the projects that are important to them and to you. And in fact, many of you probably work on the same projects with them. Over time, we've released about 18 million, 20 million lines of code via this process. And that includes large projects like Chromium, which is what goes into Chrome, Android, and others. So it's actually not hyperbole. It's not an exaggeration to say any commercial device in this room that has a chip on it is running some code that was written at Google, whether it's the camera that guy is carrying, or your phones, or the machines in back that do sound mixing. Because most of these were built using GCC, and we have such an active presence in that project. But it's not hyperbole at all. Anytime you buy a machine from Sun, anytime you do anything online, you're probably using some Google code, no matter where you are. And that's very satisfying for us. For example, how many of you are using Chrome? Just raise your hand. That's great. Wow. I really shouldn't even ask that question. It's sort of pandering. So it's important to understand why we created Chrome in the first place. We're big supporters of Firefox. It's a fine browser. But at the time, they weren't prioritizing speed. And we were really worried that people were going to find that browsers were not as exciting as the desktop, and that the desktop still offered a lot of things over browsers, and it would drive people away from the web. And there were other things that were really fairly large problems, and frankly still are in some browsers, and that was the security of individual processes in a browser and how exploitable they were. IE largely learned that lesson with IE 9 and IE 8, but still, a lot of them, how many of you remember using Firefox, using IE, and having one tab go bad and taking the whole browser with it? Just raise your hand. So that was something that really bugged us, okay? We felt that was wrong. And we would try to fix these things, but it's actually, this is a problem that exists deep inside the browser. And so we felt the way to expose how important this was to lead by example. And now we could have just released a browser and not open sourced it. But we really wanted to change all browsers, not just ours. So we released it under the BSD license, which is one of those take it licenses. We don't need you to share your code. But it's also specifically one that's compatible with Firefox's license. It's compatible with Safari. It's compatible with IE. It's compatible with all the browsers. Opera. They can all use this code, and some of them have. So that's been very, very satisfying. Similarly, about 5-6 years ago, we did a study of the mobile market, and it looked a lot like the desktop market. You had one player, Nokia, which owned about 96% of the market. And at that time, RIM held about 6-7%, and then Windows Mobile had a fraction of a percent. And that was kind of worrying to us. Because the reality is Google feels very, very confident that as long as you can reach Google, we'll be fine. We'll be able to satisfy you. We'll show an ad now and then. We'll make money. But if you can't get to us, or if somebody can stand in the way of you getting to us unfairly, then that's going to be a problem. So we looked at the cellular market, and it was starting to look a lot like the market on desktops at the time. Now, we worked on Android. We picked up a small company, Android, which was about 5 people. We funded them up. We gave them a lot of engineering talent. And we now have Android. And so we're shipping about, this is a number that had to change on Monday, and I haven't changed it yet. We're activating about 300,000 devices a day. And Android exists to basically make it very easy for vendors to create phones that can access the web well. And it's been pretty fantastic. And it does that by being a very good smartphone operating system. So now, if you look at the picture of smartphones around the world, you still see Nokia with a majority share, as most of you probably know because of their fantastic Arabic support compared to the other phones. But then you have iPhone, and then you have Android. And so you have a lot of people competing to make you happy. And this is a very good situation. You have proprietary and open source vendors working basically against each other, trying to be better. And we think that means a freer internet. We think that means a better experience for you. And so we're very happy about that. And I think Sebastian remarked on WebM for a moment during his speech. But if you, again, look at video, most of the video codecs that have been reigning the nest over the last 10, 15 years are not really designed for network streaming. To make H.264 and MPEG and these other codecs good at streaming, you actually have to do some fairly bizarre things to them. They're really not designed for that. They're designed for I'm going to pull off of a disk and play on a television or play on a projector. So a small company called On Technologies in the snowy parts of New York, they started working on their own codecs that were specifically designed to be very streaming friendly. And that resonated with us, so we purchased them, and then we open sourced their code. We didn't just open source it, we also offered a patent license saying that any patents you might exercise by adopting our code, we give it to you for free. Because if you look at the video codecs that come out of the MPEG-LA cartel, they're actually quite costly. You don't realize it, but every one of your phones in the bill of materials, there's 50 cents to $1 that they've spent on codecs. And that was something we thought was fairly unreasonable. It raises the cost for everyone. It slows down innovation. So we wanted to get it out there and sort of try to change the world that way. And this is a codec that's as good as the best codecs out there. And in some cases, it's even better. And it's much more efficient on the network, so we're very happy about that. Finally, we said, you know what? I would go to these open source conferences, and I would see a lot of the same faces. You know, they were all getting older. We weren't seeing new young people come in. It was all staying about the same. And we're like, well, how can we ensure that open source is around in 10 years, 20 years, 30 years, as people start to age out of these communities? So we created the Summer of Code. And what that does is it introduces students to open source projects by basically pairing them up with a mentor. And we pay them. We pay them $5,000. How many of you are university students? Okay, great. How many of you know university students? Oh, you all do. So what I'd recommend is you tell them about this project so we can get more Jordanians taking part. The last time we had a Jordanian take part in this project was about 2 years ago, and it's shameful. So we had Egyptians, we had all kinds of Arabs, but why not Jordan? So, and maybe you don't want the T-shirt, but I've seen what you're going to do for a mug. So let your friends know about this project. That's really great. We also have one that's for pre-university students from 13 to 18 that have much smaller tasks. So if you have children that are this age, let them know about this. This is a really fun way of getting exposed to computer science. And it's unique in that it introduces people to open source, which is different than what they'll be exposed to in school. In school, you're taught the theoretical, the algorithmic, and the rest. But with open source, you're taught users, user bugs, platform issues, and things that you're really only exposed to in real work and real jobs later. So it makes you a much better programmer, a much better computer scientist. So that's it. I'm happy to take a minute and a half worth of questions. Just raise your hand if you have one. Yes. Wait. We have a microphone person coming with a microphone. There you go. Well, yeah, but they can't hear you. The search engine? So no, not all of it. So we've released a number of papers detailing it, how it works, including our storage systems and the rest. And we've released small parts of it here and there, whether it's our memory management routines, some of our drive mechanic stuff, some of our variable handling and that kind of thing. But we have not released the source code to Google's index or search engine. So, oh, and you get a mug for that. And there's a lot of reasons for that, but what it really comes down to is to release something, I need engineers to do it, and we don't always have those handy. So, but yeah. Some, sure, but we've articulated a defensive patent stance. So when people implemented GFS and MapReduce via Hadoop and HBase, they've been fine. We've been pretty good about this. We also joined something called the Open Invention Network, which pledges that we're not going to go after open source developers who might use our patents unless they sue us first. So, no, seriously, it's, if they come after us, we're going to come back, but, there's no real, we're doing fine as a company. We don't need to sue anybody for this kind of stuff. So, yeah, there was a question over here. Is it on? It's not on. Project. Just So you're saying, why did we do Chromium instead of improving Firefox? Was that your question?
Yeah. Why didn't you just
Why weren't we better at working together with other people?
Exactly.
Yeah. So we did actually do a fair amount of work with Firefox, but we hit this fundamental stop where we felt the speed and the process model were very, very important to implement, and that's not the direction they wanted to go. So it's nothing against Firefox. I mean, it's a lovely browser, but we wanted to take it in a different direction, and so we did. We still have people who patch into Firefox fairly often, but it's nothing like the work we put into Chrome. So yes.
Right. Maybe Chris will take questions after.
Oh,
if you're
find
around.
me out back. Sorry.
Okay. Thank you, Chris.